Welcome to the webinar. The webinar will begin shortly. Welcome to the webinar. The webinar will begin shortly. Welcome to the webinar. The webinar will begin shortly. Welcome to the webinar. The webinar will begin shortly. Welcome to the webinar. The webinar will begin shortly. Welcome to the webinar. The webinar will begin shortly. Welcome to the webinar. The webinar will begin shortly. Hello everyone and welcome to the webinar. My name is Bob Went and I shall be the moderator for the webinar. The webinar is entitled The Digital Bridge and it will be presented by Karl Dalton of Siemens. There will be a short time for questions and answers at the end of the presentation, but please note that the presenter's details will be shown during the Q&A session, should you wish to contact them for further information. You can ask questions using the Q&A feature in Teams, so please post your questions as we go through the webinar. And at the end of the webinar, we'll be putting up a slide that shows the details of the following webinars. Thanks very much indeed. And I'd now like to hand you over to Karl. Over to you, Karl.
Thank you, Bob. Good morning. I'm Karl Dalton and I work within Siemens UK water team. For the last 25 years or so, I've been involved in mechanical and reliability engineering, having worked for both some service companies and several condition monitoring original equipment manufacturers. This work experience has seen me work across oil majors, food and beverage industry, pulp and paper, petrochemical and pharmaceutical, and even within the marine sector. This cross-industry insight I have gained has allowed me to challenge some of the ways the water industry has addressed condition monitoring and condition-based maintenance. Siemens currently has several engagements in UK water companies, looking at how we can collaboratively optimise the existing maintenance operations, be that through sharing condition monitoring best practices or through the adoption of IoT technology. The Industrial Internet of Things refers to interconnected sensors, instruments and other devices networked together with computers' industrial applications. This connectivity allows for data collection, its exchange, the analysis, and potentially facilitating improvements in productivity, efficiency, as well as other economic benefits. IoT in many cases is there to bridge the data voids found out in the installed asset base. Today, I'd like to address some industry challenges and additionally share some new suggested ways of thinking. I'm going to focus on the power of integration by means of considering the benefits of connecting the OT layer, the discrete functionality from the installed asset base, into a single source of truth to support a mechanism to produce risk-based maintenance tasks and plans. This will then enable the asset's condition data to support a dynamic, planned, and predictive enterprise level of maintenance. The plan always seems to be straightforward, but rarely is. In reality, there are many obstacles to overcome. What I would like to discuss is how the power of integration of multiple assets, by that I'm referring to the harvesting of utilisation of asset data in a more meaningful way, could bring enhanced value through this data enrichment. For many years, UK Water has dabbled with various forms of condition monitoring, some with success, others without. But why? Condition monitoring has traditionally been deployed towards rotating assets. That could be a motor, a pump, or a fan, or a blower, perhaps even a centrifuge. It's never, to my knowledge, been fully deployed at scale across a water company's complete asset base. Again, we ask the question, why? Perhaps that's been around the lack of understanding of what it actually can deliver, and also supported with a solid return on investment. Many see condition monitoring as an insurance policy, i.e. some financial protection against losses that you don't want. Or should we be looking at more around an assurance policy that the asset is in a healthy and optimal condition? Ofwat has now collaborated with the major water companies to produce between November of last year and March of this year the Asset Management Maturity Assessment. Ofwat, through its engagement with the sector, is looking to develop and understand asset health and resilience, building on some existing asset management frameworks to co-create a bespoke asset management maturity assessment. This looks at asset management capabilities and approaches and the data and insight used to inform decisions for the benefit of the customers, the environment and society now and in the long term. If you look at your industry peers, they're moving the goalposts towards success. But the question that challenged the water industry is, are we adjusting accordingly? Collecting and analysing good data provides a wealth of information that is key to operational efficiency. Furthermore, through operational insight, OPEX costs could be reduced potentially through the robust management of maintenance personnel's times and priorities. Additionally, there's the ability to utilise this data to help decide on when the asset is replaced, providing an opportunity to potentially defer upgrades until the asset actually needs replacing, and sometimes meets its design life, which many do not. Tech Clarity Machine Monitoring and Optimization Survey in 2020 showed that 86% of companies reported an increase in profitability, while 75% more are likely to be able to react in near real time. And supported by the 2019 Deloitte and MAPI Smart Factory study, showed that between 10 to 12% average gains in such areas as output, asset utilisation and labour productivity after they invested in smart factory initiatives. What I'm about to reveal is no surprise to many. The question I'm going to ask is, how many of you still deploy the first three of these techniques, and more importantly, why? Although an operator-driven reliability program is an acceptable maintenance philosophy, with the emergence of IoT technology, connectivity, and rich data availability, why are we not looking to harness these insights to support the asset maintenance plans more? Operator-driven reliability is very labour-intensive, subjective at best, and liable to have errors. So there's a question around the data frequency, its accuracy, and ultimately the value that it provides. To get a deeper understanding of the asset's health, you have to review all the available information to gain true insight into its actual condition. If we was to take this pump, for example, that's showing some high vibration levels, it only paints part of the picture. What else could be influencing, let's say, the high vibration on this specific pump? It could be a flow-related issue. It could be a pressure-related issue. It could be something to do with the drive. It could be structure-related, or perhaps it's actually just a bearing that's failing. If you only have part of the picture, how can you truly understand what's causing this fault presented? And how many of these other process parameters are correlated with the condition monitoring data that is measured to give the true overall condition? Let's go one step further. Sewage pumping stations are a cause for concern in most water companies. Many blockage incidents are linked to a pollution event, and in the worst case, an unconsented discharge into a nearby watercourse. These sewage pumping stations typically consist of a duty with possibly an assist and maybe a standby pump set configuration. These are then traditionally connected through telemetry, which is increasingly peaking at capacity. Therefore, additional connectivity in a lot of these applications can be a challenge for the water companies, and where there is a request for richer data, this then starts to raise issues. Other forms of data extraction need to be then considered to capitalise on the data that may already be there, which currently is just hidden. Depending on the telemetry data available, there are some typical data points that could be retrieved. Tank level data showing low and high levels, which pump is in operation, if the pump's been tripped, run hours, high ampage. This is then visualised in SCADA and graphically indicates the asset's condition. In this example, 3 pumps are in red, i.e. showing an alarm. But why? If we just enrich the data ever so slightly, we can then start to get a wider system view of the potential cause of the alarm, and not that just something is in red. Again, we take the level and pump data as before. This time we enrich it with some simple IoT to look, for example, at motor performance. In this instance, we're taking 3 axles of vibration, some electrical stator frequency data, and slip frequency. So the power of integration. How does 1 + 1 = 3? how did I arrive at this very odd answer? Here we see in the animation a standard IEC Somatic low voltage motor, which on its own is just a motor. If though we complement it with, for example, the Somatic Connect 400, we can measure temperature, which correlates to the motor surface temperature, 3-axis vibration, axial, tangential and radial, the electrical stator frequency and slit frequency. By combination of the motor and the sensor, we have this third dimension and third level of data. Let me show you how. The machine supplies the data. The sensor harvests it and securely transmits it. And by using an application to give some analytics and visualization, we can also start to consider and look at service optimization. If alongside this Somatic sensor, we use, for example, an Internet of Things app, the SiDrive IQ app can deliver additional insight and display them as shown here. The additional values that can be visualized are energy consumption, rotational speed, torque, electrical power, motor status, if it's on, off, the number of starts. It shows a fleet management view as either a list or a map view. We can start to look at asset performance data, so the number of run hours, energy consumed in its current operation and totalized. We can also start to look at some detailed KPI information. But again, we can go another step further. If there was installed, for example, an intelligent motor controller, then we can start to use the condition and operational data to then control the pump reversal to stop blockage occurring in the first place. Additionally, the intelligent motor controller can further provide performance insight of the pump set. Again, through an enabled secure connection, could be transmitted to a cloud-based platform. In this instance, we're talking about MindSphere. And this facilitates the visualization of the data to allow informed decisions to be made, as well as next step in relation to maintenance tasks. The power of data enrichment. If we actually look at this animation around the tank level data, it's useful. It gives us some insight, but it's basic data and it gives you basic information. If though we enrich this data, we can start looking at deeper insight and understanding of how the pumping station is actually operating by potentially bringing in rainfall data, showing the utilization of the different pumps, be that duty standby or assist, and when and if the pump is actually reversed. So how can this newly acquired data and rich data support a wider network view? The enriched data now allows the operations teams to easily identify sites where there are either poorer performing assets or multiples of assets against similar sites within the network. This is the insight that allows a planned and structured response by maintenance to be instigated at the appropriate time at the right location, and not a reactive response, possibly after a spill has already occurred. An ideal solution would allow us to have a fleet or asset-based overview of the condition, allow you to drill down to any poor performing sites with the potential for pollution risk, and allow you to understand the exact asset that needs to be addressed. And with the data you have, you can even optimize the right craft technicians to attend. This is how an end-to-end solution could be delivered. In order to optimize the asset's availability and proactively respond to its changes, it is necessary to detect the anomaly at an early stage. Once that anomaly is detected, then the analysis can occur. From the root cause of the anomaly, the appropriate responsibilities can be generated, be that in Maximo or SAP PM or other computerized maintenance management solutions. Additionally, to close the loop, the data is then used for further insight to consider plans for either redesign, replacement, or potentially deferment of capital investment. The power of integration can also be easily understood through a number of modular software as a service solutions with tailored dashboards. And it's important because these show you how you want to see the data. Dashboards that allow you to design and meet your operational needs, look at asset details that are readily available and at hand, start to look at what maintenance has previously been carried out and why, look at if we have to maintain and do we have to have the right spares available to do that maintenance. If we don't, can I quickly and seamlessly order them? Is there a way of actually ordering them through your other existing enterprise systems? Can I additionally view the maintenance history and activities, maybe through a logbook? The power of integration can easily be established through apologies. In this, it is important to walk before we can run. And why? As I said in my opening comments, condition monitoring has been poorly adopted in UK water, and it's sometimes due to the fact that companies have tried to run too fast and too soon into the condition-based maintenance journey. We need to start off by actually getting notified of conditional changes. We need to understand how deep do I actually want to analyze this data? Do we need to have full vibration analysis, FFT analytics? How will I then use and allow me to react in an appropriate manner with that data? And how do I use this data then to improve or optimize the process? It's important to have a step progression so value can be measured and supported through a return on investment program, which then allows the funding of the next level of investment. As I said earlier, the plan seems to be straightforward, but rarely is. This is where collaboration proves invaluable. It's simple to start this journey and also potentially free. Why try to invent something internally that is already available and now offered free to try? It's secure. The data always belongs to you as the customer. You can always use existing data from either your Azure or AWS data lakes to enrich this data. And if it doesn't serve the purpose that you're looking to trying to achieve, you can come away at no cost. The data is yours then to be harvested and taken back. So with this, what I'm actually offering is the wider water industry is the opportunity to collaborate and work with Siemens through some innovations that we've already developed internally, or to support your existing developments that you may have around app development and digitization, to see how a open platform such as MindSphere can support that can either work as a separate instance included within either your Azure or AWS instance itself, and support this transition towards this digital bridge of harvesting data, not that's just taken from the existing telemetry data, but complemented through IoT. Some of the apps that are included are Visual Analyzer, which improves the efficiency and profitability by comparing data. We have a Visual Flow Creator application, which allows you to look at data at a glance by creating your own dashboards. There's a developer cockpit which allows you to develop and manage your own developed applications in MindSphere. So if you're already started the journey and you're developing something potentially in Python, and you want to look at how you can bring that into a platform for readily and easily deployment, this could support that. And finally, Fleet Manager, which enables you to monitor, visualize and analyze assets and the aspects of them. Appreciate your time and what we've delivered today and what we've talked around. One of the things that I would like to do is just to remind you that my colleague Paul Hingley will be presenting tomorrow at 2:30, and that's applying the IEC 62443 standard, as this is an integral part in the adoption of any connectivity process, and I'm sure will give you some real insight and knowledge of how Siemens has been developing and supporting this strategy as we move forward. I appreciate your time. Look forward and welcome any questions that you may have. Please, as Bob said, could you post them in the chat? And thank you very much.
Thanks very much indeed, Karl. Thank you very much. I do have a couple of questions for you, Karl, but before I go into that, could I encourage everyone to please post your questions in the Q&A area? and I'll put them to Karl as and when I receive them. The first one I've got for you, Karl, is that in your opinion, how far is the UK water industry behind other sectors, such as food and beverage, in relation to connecting assets?
Thanks, Bob, for that question. Yeah, it's interesting. Like I say, I've spent a lot of time working throughout industry in different sectors, and the maturity of some is greater than others. I would probably say oil and gas is probably the most mature, but food and beverage is certainly up there in my opinion. And I think the UK water industry is making a significant headway into catching up with the other sectors. Food and beverage, like I say, does appear to be ahead of the curve, but my question would be, is this down to the level of automation that they have, or is it down to sort of manufacturing pressures? They are behind is the answer, but certainly are starting to catch up quickly, which is encouraging and interesting to see.
Thanks for that, Karl. Another one for you I have is that this is one area where traditionally companies have looked at the benefit of carrying out this work. In other words, how much money is this going to save me? Why should I invest into this sort of work and project? How is this going to save me money, and how can you demonstrate that it will reduce my OPEX? Have you had any experience of that, Karl, that you can relate to?
Yeah, I've seen this quite a bit across different industries, but certainly I had a conversation not too long ago with one of the UK water companies that I'm engaged with, and the fear is that by using condition-based maintenance and condition monitoring technologies, that this potentially, there's a fear that by generating the reduction in OPEX, so by using the technology and information to go to the right asset at the right time to perform the right maintenance, so don't be using calendar based and being reactive, being planned and proactive, potentially would internally then be reviewed as an enabler to look at reducing headcount, which for me is the wrong approach. This is probably financially driven. And my response would be to that any operational savings in engineering time and cost of labour and parts could be offset and used to invest in them doing more proactive maintenance, and this then would drive a more thorough deployment of condition monitoring activities. So it's not a case of reduced heads. For me, it's more of a case of actually deploying them in some other application. So maybe a field service engineer becomes potentially a part-time condition monitoring technician as well. So his time could be utilised that, which allows then to get greater insight into the assets and obviously gain greater rewards. So that would be my sort of feedback on that question, Bob.
Okay, thanks, Karl. Got another one here for you. On the pump example earlier, please could you re-explain how the combined data sensors and integration help creating insights and actions and future prevention?
So yeah, some of the graphics that were shown have been extracted from an application Siemens have co-created and developed with another water company around what's called the Sewer Pump Guardian, which we presented at one of the Pump Centre webinars earlier this year. So really what we're looking at is it's looking at the optimization of that pump set. So in effect, looking at its consumed energy, its efficiency, and really blending the data in that's currently there, but not necessarily brought into this single source of truth, and then having that enabled into a single pane of glass that allows you to look at the asset's performance against operational requirements. So for example, it may be that as the wet well pumps down, it's looking at the efficiency of the pump as it pumps down, but maybe the wet well fills back up again, for example, because you got a failing non-return valve, which in some instances can be missed because those data sources aren't necessarily always collated in the like I said, this single source of truth.
Thanks, Karl. Can I just say to everybody, please, that I'm going to plough through as many questions as we can get through in the time that we have available. But please do make a note of Karl's contact details, as you see on the screen here. And if we can't get to your question, I do apologise, we'll have run out of time. But I know Karl will be very happy to hear from you and answer any questions that we're not able to cover in this session. But Mazin says, this is a wonderful presentation. Could you please share the slides? Well, Mazin, we're going to be putting up a recording of this on the Pump Centre website, so you'll be able to have a look at it there. Another one I've got here for you, Karl, from Anonymous. MindSphere 3 is a potential game changer. Can you reiterate the limitations around that offer?
So the offer is fluctuating, quite frequently, different offers that they're actually having. So what we actually say is take this on a case-by-case basis with the actual person that's interested if they want to contact us directly. I'm currently working now with a couple of water companies where they're looking at taking this offer and using it. It's a limited time, and this is where we need to ensure that when we deploy it, it's on the right assets and it's prepared and correctly built so that you get the maximum value out of it. But yes, it is a game changer because we believe that Siemens, the MindSphere solution can bring value and be a supportive tool and a collaborative tool. So I would rather say, if we can, Bob, we'll take it as a case-by-case basis, but more than happy to explain to the individual directly.
Thanks, Karl. And as I say, everyone, if you'd like to make contact with Karl, I'm sure he'd be happy to hear from you. Karl, I think we've just got time for one last question very quickly, which is, what is the added value of this Siemens solution applied to the pump industry in the face of competition?
I think the value for me is being able to bring in through an open IoT platform, which is secure as well, data that currently may be hidden. And if you look at some examples where I've seen recently where the SCADA system is almost at capacity, there's a drive through, for example, pollution strategy managers within a water company to get more data out and enrich that data. The solution provides that vehicle to do that. It allows us agnostically to connect, so agnostic when it comes to vendors of other pumps. So it could be another pump manufacturer has its own cloud. We can pull their data in as well. We can take operational data, sensor data, and bring that into this blended overview of an actual asset's overall condition. Spending years and years working in condition monitoring industry, we'd always focus on the bearings. We'd look at the impeller, we'd look at a stator, a rotor, and things like that, and never really bring in a lot of the operational data, which for me has got the value in it. So that's where I see it being supportive and collaborative. I'm not saying it's there to take over on what you're already doing, but certainly support you moving forward.
Okay, thanks very much indeed, Karl. I'm just going to bring up my my slideshow again. Right, there we go. Okay, yeah, thanks very much indeed, Karl, for the presentation, and I'd like to thank all of you out there for attending. Do remember that if you want to follow up on any of the questions or ask Karl any more questions, please do so using the contact details that you saw. And also don't forget to visit the company's stand at the exhibition. I'm sure they'll be pleased to see you there. I'm going to show the next two sessions on the following screen, and I hope you can make them. Look forward to seeing you there. But for the moment, thanks everyone, and goodbye for now. Thank you.